want to write these expressions in the simplest way that we can. And if we can evaluate them, that'll be something we'll try as well. So one of the things that we're looking at with our new formulas is you have to be able to recognize when you have a formula. And just like your sine squared plus cos squared equals 1, and tan squared plus 1 is secant squared, and cotangent squared plus 1 is cosecant squared, I would like you to have these formulas mostly memorized. Okay? By mostly memorized, I want you to be able to say, hey, I have sine cos minus cos sine. That's one of them. If you don't remember that that's the sine alpha minus beta one, you have to look on your formula sheet to verify which of the four it is. That's fine. But you need to be able to recognize that if you have four trig functions in this order with sine and cos, that it's probably one of our sum and difference identities. And we look, we've got two angles the same here, two angles the same there. So this would be our alpha, and these would be our betas. Which one does this match with? It matches with sine alpha plus beta, sine alpha minus beta. So we could write the left-hand side of that identity. And can we simplify this further? Yes. This just becomes sine 5x. Well, that would be the thing. Once we look at all four of those, and I'll just show you up here on the board over here, you've got sine cos minus cosine, sine cos plus cosine, cos cos plus sine, sine cos cos minus sine sine. So this one doesn't match with the cos cos ones, but it does have a sine cos and then a cos sine. So it matches with the sine one, and with the minus sign in between, then there's a minus sign in between the alpha and minus beta on the left-hand side as well. So that's one of the, you'll have, these are on your formula sheet. So you just have to verify which one does this match with. And sometimes you'll have to rearrange things a little bit for it to match up perfectly. Because I could write this, you know, just to see if they could if you're able to rearrange things. Can you see that I've just written the same equation? What have I done? I switched the sine 3x and the cos 8x. So this might happen to see if you know that multiplying doesn't matter the order. And that still matches up with that formula. So that first one is just sine 5x. That's simplified. Again, having your formulas mostly memorized, for your tan formulas, you're going to remember, hey, if there's a lot of tans in a fraction, it might be one of my identities. So here I have tan pi over 6. I'll call this my alpha, alpha, this my beta, alpha, beta. Does this match with one of our formulas? Is it alpha plus beta or alpha minus beta for tan? Alpha plus. So then I would have pi over 6 plus pi over 12. Can this be simplified further? We could add these two together, right? Get a common denominator. 2 pi over 12 plus 1 pi over 12 would be 3 pi over 12, and that reduces to pi over 4. Can we simplify that further? Yes, that's on our unit circle. Tan of pi over 4 is 1. So with these new identities, part of what you have to be able to get good at is recognizing them. If I have the right side of the equation, sometimes it's going to be helpful for me to realize what's alpha, what's beta, and write it as the left side of your equation. And if I have the left side of the equation, sometimes it's going to be helpful to write it as the right side of the equation. Okay, questions for this one are 4 and 5.